Hello everyone, welcome back to the class, and in today's class we are going to cover the concept resolution of a vector from motion in a plane. So in the previous classes we would have seen that how to add two vectors, right? So in this class we are going to learn how to resolve vectors. Okay, and with that note, my name is Mohana. I'm a physics educator here at Unacademy, and if you're taking your class 11 and 12 physics, I'll be teaching here. And this is my Telegram channel link, so if you have any so you can follow me on my channel, as well as this is the common Unacademy ICSE and ISC both channels, so you can follow this Telegram channel as well. All right, and with that note, alright, so just like how we have the classes, these special classes on the YouTube channel, right? We also have some free classes on the Unacademy platform. So these classes, we actually call them as the special, special classes. Okay, so you can take any of your favorite educators classes for free, and you can engage with these educators via this pool feature. All right, and if you have any doubts, and since these classes are also live classes, you have any doubts, you can get them cleared then and there. Okay, and the link to the upcoming classes are down in the description box. So you can just click on the link and you can go to class 11, and all the upcoming special classes for this month would be there, and you can enroll in all of them. You can just click on the notify button. As soon as the class is about to go live, you will get a message. All right, so the next special class, this is actually tomorrow. This would be is at 7:45 p.m. right, around the same time as your YouTube class, but it will be on the Unacademy platform. So today's class we will learn what a resolution of a vector is, and tomorrow's class we will see what is the applications. Okay, now next class would be on 8th July. So we had been doing on the Unacademy platform last month onwards, we had been covering your unit 3, that is we had been doing dynamics, especially the concepts from laws of motion. So this will be a continuation of the same. Okay, and don't worry, we would again be taking a new topic in laws of motion, and then we would be learning about that as well. Then the next class would be on 13th July. This is again at 7:45, same timing as here. This is on the Unacademy platform. Now, when you did the unit 2, we did motion in a straight line, right? We studied about displacement, velocity and acceleration, right? So now next in this particular class, we will do a graphic analysis of the same. All right. Now, in case if you're interested with the plus subscription, right, these are the features you would get along with it. One is you can learn from the comfort of your home. Next, you have unlimited access to all courses, meaning whenever you're taking a plus subscription, you're getting 4 subjects with Unacademy. You'll be getting physics, chemistry, math and biology. You're getting 4 subjects with Unacademy. Okay, so you'll get unlimited access to all of these courses, and you're learning from the top educators, and as well as every 4th session is always a doubt clearing session. In case if you had missed the previous classes and watching the class recordings, or if in case you still have some doubts with any of the concepts, then you can again clear all of your doubts cleared on this doubt clearing session over here. Okay, and in the plus course we will cover your entire syllabus, and there are also many practice tests available, and other than this, every other week there will be a live test series, right? So right after the test series there will be an analysis session as well, so you can get, in case if you got any of your questions wrong in this test series, you can actually learn the right method as well. Okay, and the coming up batches, I will tell you about the upcoming batches shortly. And now with Unacademy, the longer duration you take a course, the price per course goes down. So if you take for 1 year, let's say the price is around 1,438 rupees per month. But if you're taking for 2 years, then per month you're paying only 1,198 rupees. Okay. On top of it, if you're using my educator code MTIS10, then you're getting a 10% discount. So in that case, instead of paying 1,198 rupees, you'll be paying only 1,078 rupees per month. So you'll be getting a 10% discount of the same. Alright. So with that note, the price might hike soon. So if you're planning to take a subscription, you can actually take this limited period offer. This is for both ICSE and ISC board learners. Now, in case if you take a 1 year subscription, all right, then you get 1 more month your plus subscription for ICSE and ISC board, whatever course you're taking, right? If you're taking class 12, class 11 subscription for 1 year, then you'll get 1 more month free extension on the same. At the same time, you'll get a free creative corner of about 3 months. Okay, so these are your creative courses that you can getting for about 3 months. You're getting this extension. All right. Similarly, if you're taking 18 months course, then this is again 1.5 years. Then you get 2 months plus subscription, right, and a creative corner of 3 months. And if you're taking the 2 years course, then you get paying for. You're getting a plus subscription of 3 months free, along with the 6 months extension on your creative corners. Okay, now this offer is only between July 15th to 5th to 8th. So if you're taking a plus subscription, this would be the best time to take. And to avail this offer and top of it a 10% discount on your subscription price, you can use my code MTIS10. Okay, so the upcoming batches we have for class 11 are are actually this Brahmastra batch, right? So this batch is going to start on July 6th. That is actually from tomorrow. The course is going to be taught in English. And in a plus batch, again, we have math, physics, chemistry and biology, 4 subjects. And for physics, we meet between 5:15 to 6:15 every Tuesday, Thursday and Saturday. So the course, the plus class duration is about 1 hour. And math, Rahul sir will be taking, chemistry, Manisha ma'am will take, and biology, Lakshay sir will be taking. Okay. Now, if you're in class 11, you're in advantage. If you're taking a class 11 subscription, okay, then you're getting a class 12 subscription absolutely free. So if you're taking about a year subscription of class 11, your class 12 subscription is completely free. Okay, so you can make use of this offer over here. The focus of this Brahmastra batch is going to be a midterm syllabus coverage. So we'll be covering your first 5 units. Okay, in case if you're missing any classes, class recordings will be given, and in the doubt classes you can ask any questions that you have as well. Okay, so normally if you see per month, right, you will have a minimum of 10 classes in each subject. So in a month, if you see, you are at least getting 40 hours for minimum of 40 hours for all these 4 subjects. That is 10 hours for math, 10 hours to physics, 10 hours for chemistry and 10 hours for biology. That's the minimum number of hours you'll be getting. All right. Now, similarly for class 11, how we have class 12 also, there is a batch that is going to start, and this batch is going to start on July 6th. Okay, and again the board of the course is going to be taught in English. Right, and for class 12, for physics, we meet between 5:15 to 6:50 p.m. between Monday, Friday and Saturday. This course's focus is also your midterm syllabus coverage. All right, so your first 5 units will be covered. And Riddhima, good evening. And with that note, let's come towards the motion in a plane. So when we started the concept of motion in a plane, we learned the difference between what is a scalar quantity and what is a vector quantity. So if you know the difference between what a scalar and a vector quantity is, you can actually share it in the chat box. Right? What do you think is a scalar quantity? Okay. Whenever you're talking about a scalar quantity, it only has a magnitude. It has no direction. Okay. For example, mass. When you're talking about mass, let's say a bag of rice is around 5 kgs. That's a scalar quantity. Okay. When you're talking about a vector quantity, it has a direction as well as a magnitude. And other than that, one more important point, they have to obey the vector law of addition. For scalars, you can add using ordinary algebra, but for vectors, you can add only using the laws of vector addition. Okay, Riddhima, scalar only direction, that is correct. Okay, and a vector quantity has both magnitude and direction. Okay, now I have a question for you guys. What do you think about velocity? Is velocity a vector quantity or a scalar quantity? Alright, so think about that. Now, how do we represent a vector? We have done this in the previous class. Short, quick recap. Okay, this is the head. We call this as the tail or the initial point. So this is the starting point of the vector. The length of this vector tells us what is the magnitude of a vector. And this head over here, the arrowhead direction, right? This we call it the head or the terminal point. This shows us the direction. Okay. So if you want to compare 2 vectors, let's say there is a vector which is in this direction, right? Which is in the direction as this vector. Let's say this is around 40. Let's say this is showing 40 meters per second. Okay, so this vector, there is another vector, means if it's half its size, it will be 20 meters per second. vector velocity, Ridhima, velocity is actually a vector quantity. Velocity is a vector quantity because velocity is actually whenever you're talking about velocity, we are talking about displacement by time. Velocity is actually displacement by time. Okay. All right. So velocity, displacement over here is a vector quantity. So your velocity, which is displacement by time, is again a vector quantity. Okay. And Ridhima, acceleration, when you're talking about acceleration, that is again velocity by time. Displacement is a vector quantity, velocity is a vector quantity. So acceleration, because it's velocity by time, this is also a vector quantity. That is correct, Ridhima. Acceleration will again a vector quantity. Okay. What do you think about speed? What do you think about speed? Is speed a vector quantity or a scalar quantity? Okay, so on that note, okay, so this is your representation of a vector. Okay, so whenever we represent a vector, let's say this is talking, let's say this just telling you speed is a scalar. That is right, Ridhima. Speed actually talks about distance by time, distance or the path length. That is actually a scalar quantity. So speed is a scalar quantity. So whenever you're talking about a vector, let's say this is actually giving you the direction. Let's say there is a car that is going in this particular direction with a speed of 50 meters per second. Okay, and this being it is going in the east direction. Okay, then velocity is always represented with the arrowhead on top. All right, that's how we represent a velocity. Now, represent a vector. Now, last few classes we actually covered how to add two vectors. Right, very simple. Let's say there is a object over here. Okay, or let's say there's a marble over here. Okay, let's say that this marble is actually given a velocity, so it moves a certain direction from here to here. Okay, and once it reached over here, let's say it is given another velocity, meaning you're hitting it with some other object and it gets a velocity in this direction. So it was here initially it was displaced once, and again it was again displaced another time. Right, so you can say this is A vector and B vector. Right, now there are two different forces. This is A vector over here and then you have a B vector. Right, how do we add these vectors? Okay, what would happen? Instead of using two vectors, that's said, okay, one vector, resultant. What is a resultant vector? Yeah, sure. Okay, very simple, Ridhima. Let's say there are two vectors. Okay, so let's say this is A vector that is going in this direction. Let's say there is another vector which is actually B vector which is going in this direction. Okay, now if you add these two vectors, what would be its result? Okay, that would be resultant of a vector. Okay, you can't just add vectors by like how we had scalar quantities. That way we cannot add vectors. Okay, you can only add vectors through geometrical laws. Okay, what these two vectors, okay, effect of these two vectors, if you could express it with just one single vector, that is basically called as resultant of the vector. Okay, now the process by which you are adding these two vectors, that is called as composition of vectors. Now there are three different laws for actually vector addition. One is triangular law of vectors. So here I told you there is a vector in this direction and let's say there is a B vector in this direction. Now the resultant of these two vectors you can find by using the triangular law of vector addition. Meaning, let's take a triangle. Okay, let's take a triangle. Triangle has three sides, right? So what we are going to do, we are going to keep these two vectors as two sides of a triangle. Okay, we're going to say this one side of a triangle is A vector over here. And where this A vector ends, that is the terminal point over here, from here we are going to start this B vectors. Okay, from this point we are going to start the B vector and we are going to say B vector is in this direction. So this is A vector and B vector. We cannot normally add vectors, we have to make use of geometry. Okay, and one of the vector laws is triangular law of vector addition. Now you have two vectors right? Now the resultant vector will be the third side of a triangle. If it has a third side, so this is basically a triangle, right? It has two sides. Two sides forms A and B vector. Now the third side, that is, you start from the initial point over here and end at where this B vector is ending. Okay, so this is your resultant vector. Okay, so you can take it as an example like this. Okay, let's say a billiards ball is over here. Okay, you strike it with a striker, right? Where you strike it and it moves to this point over here. So a particular velocity was given to a ball for it to move from here to here. And from here, let's say, okay, the pocket is over here. Okay, from here, okay, or let's say you have a carom coin over here. Okay, from here you hit the coin, right? You give a particular force. So when you're applying a particular force, what is happening? The object is covering some distance with time, right? So it gains a particular velocity. So getting a particular velocity, it moves from here to here. Okay, now let's say the pocket is over here. So you keep your striker here and you hit this over here. Okay, now let's say it moves particularly in this direction. Okay, you couldn't pocket it, but it ends up somewhere over here. Now what you have? You basically have two vectors, right? It was one vector which actually went from here to here. This is your A vector, right? A vector first when you move the coin from here to here, B vector when you moved it from here to here, right? Resultant of those two are very, very simple. Instead of using these A vector and B vector, if you can represent it with one single vector, that is, this is where the initial point is, right? And this is where the final point, the striker reached. It did not go to the pocket, but it reached here, right? This is where the coin reached over here, right? From the initial to the final vector, joining the A vector to B vector, right? If you do that, that's resultant. So this is A vector plus B vector. Okay, so this gives you the resultant of the vector. Clear? If you guys have any doubt, if any of you have any doubt, you can again ask me in the chat box. Alright, so this is basically triangular law of vector addition. When you're saying triangular, you can add only two vectors. Why? Two of the vectors, okay, when you're talking about two of the vectors takes two sides of the triangle, the result of those two are taken by this side. Okay, now next one is parallelogram law of vector addition. Okay, for this, very simple, even using parallelogram law of vector addition, you can actually add only up to two vectors. Okay, let's say you're playing a marble. There's a marble here. Okay, let's say you're hitting this marble. Okay, your friend is also hitting this marble. You hit the marble and this gains a velocity in this direction. Okay, let's say you're hitting the marble and it gains a velocity in this direction. Okay, same time when you're hitting the marble, your friend is also hitting this marble over here. He also lands up hitting your friend also lands up hitting the marble over here, and it again gains a velocity in this direction. Now the marble, wherever it was, it has gained two velocities. One is by what your friend applied, and another is the velocity in which you hit the striker. Right? Now there are two different velocities acting on the same object. Now what will be the resultant? In which direction will it move, and what will be its magnitude? That is again, in this case, if you see over here, if you see, this vector is starting point, both the tail ends are starting from the same point. Okay, when that happens, this is called as a co-initial vector, meaning both the vectors are starting initial points are same. It's a co-initial vector. Now to find what will be the resultant of these two vectors, we have to make use of a parallelogram law of vectors. So what we are going to do is, we are going to imagine that these are the two sides of a parallelogram. Okay, and from here we are going to draw a line, and from here we are going to draw a line. So what do we understand from here? These two sides are equal, these two sides are equal. Now the resultant of these two, okay, will be diagonal to this parallelogram. So this is going to be a resultant vector, A vector plus B vector, right? Again, using parallelogram law of vectors, you can add only up to two vectors. Okay, so these are the difference between triangular law of vectors and parallelogram law of vectors. Triangular law, when you took A vector was in this direction, again B vector started from the head of A vector. right? And from initial point to final point gave you the resultant R, right? But when you're adding using parallelogram law of vectors, we are going to see that both are co-initial vectors, meaning the two equal. You can think of an example like, as I said, you're playing marble and both you and your friend ended up hitting the marble at the same time. So two different velocities was given to the object. So using parallelogram law of vector addition or triangular law of vector addition, you can add only up to two vectors. Clear? If you have any doubts, again you can ask me in the chat box. Now other than this, there is one more law, that is polygonal law of vector addition. Polygonal means what? An object, okay, or a shape that has many sides. So polygonal law of vector addition means you can add more than two vectors. At that time we go with polygonal law. For example, let's say this is A vector, okay, and let's say B vector is acting in this direction, okay, and let's say C vector is acting in this direction. You can think of a football ground, right? Football was over here. First player kicked it in this direction. Let's say second player kicked it in this direction. Third player is kicking it in this direction. The fourth player is passing the ball, right? Let's say he again kicks it in this direction. Okay. Now, initially the ball was over here at this point. Now, finally it is over here. Now, how would you give this using the resultant? The resultant of all these vectors would be where? It would be from this part. This is this initial starting point and this is where it is finally, right? So, this would be your resultant. And this resultant R will be sum of A vector plus B vector plus C vector plus D vector, meaning instead of all these four vectors, the effect of all these four vectors, right, you can give it by this one single vector that gives you the magnitude as well as the direction. Okay, this part we have covered in the previous classes also, and I hope this is clear. If you have any doubts, again you can ask me in the chat box, because we will be moving on to what is the resolution of a vector. Okay, till now we did composition of a vector. Composition means adding. Remember, having two or more vectors, when you add these individual vectors, what is the final effect it produces? That we are just giving it by a single vector. That is adding or composition of a vector. Now, resolution of a vector is very simple. Opposite of composition of vectors. Okay, great Ritima. All right. Okay, so resolution of a vector is just opposite. Now, if you take one resultant vector, okay, let's say the resultant vector is R vector this way. And if you can split this vector, okay, such that if you combine the split vectors, it will give you this R vector. Okay, that is actually called as a resolution of a vector. Alright, and the vectors into which the given vector is split are called component vectors. Alright, resolution is the opposite of composition. Having a resultant vector, now we are going to split it into different vectors. Okay, or we are going to split it into its component vectors. Alright, now let's say there is two vectors. Let's say there is a vector R over here. Alright, now this vector we have seen, let's say this is in the direction of OQ. Alright, now for example, what we are going to do is we are going to extend this, right, and we are going to extend this side. Okay, now this is in X direction and this is in Y direction. Now from here we are going to say, okay, from here the point where they are meeting, let's name it as P. Okay, from here we are going to say from the starting to this point over here, there is a vector going in this direction. Okay, let's say that is actually, let's say this side whatever is going in, okay, this way, let's say this is A vector, okay, and it has a particular magnitude, and to represent that we have a particular magnitude, we will use a Greek symbol lambda. Okay, similar to this, okay, from here we can actually say there is another vector that's going in this direction. Okay, this is B vector. Okay, and let's say to say it has a particular magnitude, we will use another Greek symbol, and let's say that is basically mu. Okay, let's keep it like this. Now, we saw this according to triangular law of vector addition. What did we see? This O Q vector, that is this vector over here, will be OP vector, this vector, plus PQ vector over here. Okay, this vector that you're seeing will be this vector plus this vector. Alright, now from here we can actually say this OP vector is what? From here what can we actually deduct is this OP that we are seeing, no, this OP, this is parallel to A vector, okay, and it's equal to lambda into this, right? This side OP of the triangle, okay, this side OP is parallel to A vector over here, and it is equal to lambda into A, lambda being a scalar quantity, some magnitude, okay. Now, another side is there, that is PQ. Okay, this side PQ is again equal to B vector. Okay, Rishabha, hello, right? This is mu into B, meaning it has some magnitude. Mu is a scalar quantity, it has some magnitude into B vector. Okay, so here this PQ is what? This is parallel to B vector over here. Okay, so from here you can say your R vector, right? The resultant R vector is some magnitude, right? Scalar quantity into A vector plus some scalar quantity into B vector. That's the resultant magnitude. Okay, so you can resolve, you can actually, what do we say? You can resolve this R vector into two components, right? One being in this direction, that is your that is A vector, and another in B vector. All right. Whenever you resolve a vector, you can only split them into two. Okay. So as you see, in two different directions. Okay. So here you can say the vector R can be resolved only in two directions, that is in the direction of A and direction of B. So opposite of composition is resolution of a vector. Composition means you're adding vector. Resolution means you're splitting the vectors into two or more vectors in such a way, whatever their combined effect is, right? When you combine these two vectors, you will get the same vector R. We saw this in triangular law of addition, right? These two vectors, if you combine, you get this. Okay, and these two components, the resultant vector, in which way you split, right? These two are called as, this is A vector and B vector, right? Those two are called as component vectors. So these are the terms. So you've learned what is composition or addition of a vector. You've learned what resolution means, okay? And you've learned what are these component vectors. Component vectors means here A vector and B vector. Resultant is split into A vector and B vector. Those are the components of the vectors, okay? One more question might come in this, so make sure that you know what are these different terms are, right? Now, let's see what is a base vector. A base vector is very simple quantity, okay? Let's take a Cartesian coordinate system. You want an example of the vectors getting split. Walking is actually an example of resolution of a vector, Ridhima, and we are yet to complete. We are still seeing the basics of resolution. We will be seeing how to split. What are the two components that you're seeing, right? What are this component, this one? We will learn that, and I'll give you one more example. I'll give you the walking example after that, okay? Because if I tell you right now, you may not get it. Okay, right now again. So let's see what a base vector is. Okay, now let's take the Cartesian coordinate system. So this is actually your x direction, right? This is your x, y coordinates and z. Right? Now let's say there are three. Let's take three vectors on this quantities. Okay. Let's say this is your I vector. Okay, or I cap. All right. And along the j vector you have j cap. Okay, along the z over here you have k cap. What do you mean by this cap that we are seeing over here? These are unit vectors. Whenever you say something as a unit vector, right, their magnitude, okay, their magnitude is 1. Since their magnitude is 1, it becomes very easy for us to use them in our calculation. Okay, so how do we get something as a unit vector as 1? You can think of it, you will be learning more about it in your math classes. But for example, let's say this vector that you're seeing over here, let's say this is in the x direction, and let's say this vector is around 3, 3 into 3a vector. Let's say this is 3a vector, right? This is a vector which magnitude is around 3. Okay, so if it has this a vector has a magnitude about 3 means what we are going to do is, hello Rishabh, good evening, and what we are going to do is we're going to split this into unit vector. Let's say I'm going to split it into small unit vectors. Okay, I'm going to say this vector has a magnitude of 1, this vector has a magnitude of 1, this vector has a magnitude of 1. All three added together again gives me the same a vector. So a vector, we said it has a magnitude of 3, right? Now these three unit vectors that we have taken, unit vector has a magnitude of 1. Okay, that we have taken as a magnitude of having a magnitude of 1. This is how many vectors are there? 3 vectors are there. So we can say 3 into a cap. That again gives you the same length of the vector. Only thing we have done is we have made this unit this vector into a unit vector. So each magnitude is actually 1. Now it becomes easy with calculation. Okay, so whenever you see a unit vector along your x-axis, conventionally we take it as I. Okay, y-axis unit direction, again we take it as j. Okay, and z-axis we say k. In all these 3 cases, it's in the positive direction, right? We have taken the positive x, y and z-axis, right? Now, if you see these 3 mutually perpendicular axes, if you see these 3 vectors, they are mutually perpendicular to each other, right? So these 3 vectors, we can collectively call them as your base vectors. The 3 vectors which are mutually perpendicular to each other, right? And these are again unit vectors. These you can call it as base vectors. Always remember, we use this as a convention, like how we have given this positive x direction. Likewise, when we take x direction, we always take the unit vectors as I cap. Y direction, we usually take j cap, and z direction k cap. That is like conventionally we take that value. Alright. Now, from here we'll see what are the rectangular components of a vector. Right? We saw what are component vectors, right? Now, what are the rectangular components of a vector? Okay. Now, if you have, when a vector is resolved along 2 mutually perpendicular directions, okay, the components so obtained are called as rectangular components of a given vector. For example, let's say we have a vector here. Let's say we have a vector, all right? And this vector that we have over here is, okay, let's say this is my R vector. Okay, sorry, because resultant we always use R, right? We'll take a different alphabet over here. Let's say this is A vector. And from this point that you're seeing over here, let's give this a name. Let's say this point origin is O and this point over here is P. So the vector is along this axis. Okay, and this is A vector. Now, this is a result. This is one vector that we have over here. Now, if we are going to resolve this vector, resolving means to split the vectors, right? Now, to do that, okay, from the initial position, right, we will take 2 axes, right? From initial position, we are going to take 2 axes. From here, we are going to take x-axis, and from here, we are going to take y-axis. Okay, and let me also do this. Let me just reduce the size as well. Okay, now from here we can actually see, right? From here I can actually see what we are going to do is we are going to take 2 points from here on the x and y axis. From here I'm going to drop a line, okay, and let's name this as M. From here I'm going to drop another line from this point to the y axis, and let's give it as N. All right. And something over here that you can note is this ON, it's parallel and as well as equal to this MP, this side. Okay, similarly, it's a rectangle, right? So, OM is equal to again NP. These 2 sides are equal, okay, and these 2 sides are also equal. These 2 sides are equal, these 2 sides are also equal. Okay. Now, if you take parallelogram law of vector addition, right, what can we say? From here, according to parallelogram law of vector addition, we can split this P vector as OM vector, okay, and we can split it into another vector which is basically ON vector. Alright, now this vector that is in this OM direction, we name it as, we will basically name this as, because it is in the A, it is splitting of this one A vector, but since it is in the X direction, we give it as AX vector over here, and because this is in the Y direction, we can give it as AY vector over here. Okay, single vector we have just split into two different components. Okay, now when we did resolution of vectors, we saw whatever the resultant vector is, alright, with respect to the x-axis direction, right, with respect to the vector over here, right, down below, okay, this angle will be theta, meaning, right, if you know what is this angle over here, right, if you know this vector, from this vector you can say, you can go 10 degrees or 20 degrees, whatever this theta degree is, that will actually give you the direction of this P vector. Hello Abhishek, right, so this angle over here is theta. Now, according to parallelogram law of vector addition, right, here we can see that you can say that this A vector, Abhijay, hello, okay, so over here you can say your A vector that, so over here you can say this OP vector, right, this OP vector over here will be equal to what? Will be equal to this OM vector, okay, plus ON vector, right? Why we can say that this ON vector is equal to this? If you take this side, okay, and also parallelogram, and also vectors are actually, it follows, it is associative as well as commutative, right? Vectors are associative and commutative, meaning whatever this length is, it is actually equal to this length over here. So I can just move this vector over here as well. Okay. But if you're seeing what is parallelogram law of vector addition, from there, good evening Rishabh, from there we are able to see this resultant vector is basically the sum of this vector and this vector. Alright. So here we can say, this, from here you can actually say this is nothing but, OP vector is nothing but your A vector is actually a sum of this AX vector, right, plus AY vector over here, right. So that gives you two components, all right. One is your X component, this vector is actually resolved into two components, okay. One is your X component. Abhishek, I teach class 11 and 12, okay. Another is Y component. These are the two components which is split into, okay. X component, if you see X component, in this side if you're seeing, this is horizontal, right? So sometimes we call this as horizontal and this we call it as vertical component, okay. So X and Y components are horizontal and vertical component. So any vector is resolved into two components. The two components are horizontal vectors and vertical vectors. 1 marks, be sure about these terms and what we are using it for, okay. Now, let's take unit vectors along this, right. Whatever we did over here, let's take unit vectors, meaning let's say we have the resultant vector in this direction, right. This was a resultant vector. This resultant vector composed of two things. One is this was split into two vectors, right. So to do that, from the end, drop into, from the origin, take x-axis and y-axis. From the top, that is where the vector is ending, drop a line, okay. And from the origin to this point over here, this will give you your horizontal axis, right. And this will give you your vertical component of the vector, okay. And always remember, you can shift these vectors as you like, right. The same vector, you can actually do the same vector. Let's say this is A vector, right. you can actually, and this being the stops and these two sides are equal, meaning since these two sides and these two sides are equal, we can shift the vectors. Okay, so if this is a vector over here, this is ax vector over here, means this being ay vector, you can shift it over here and you can say this is ay vector. Similarly, this ax vector, you can shift it over here and you can say this is ax vector, which basically gives you your vector law being commutative and associative. So you get one triangle, see, from here to here and from the end to the from the starting point to the end, you get one triangular law of addition you can apply, and again for this side also you can do the same. Now given this over here, let's take them along their unit vectors. Let's take these because there are two vectors over here, right? Let's apply them unit vectors because it becomes it will become Ridhima, you want explanation for the second graph? Okay, very simple, Ridhima. See, this is a vector, right? So if you take these two sides over here, if you see, whatever you're taking as this side over here, okay, it's equivalent to this side. Okay, these two sides are equal, right? Now, whatever you're taking as these two sides are equal. So you can shift the vectors actually. All right. So for example, if this is your ax vector, means as given in the picture, right? If this is your ax vector, right? Now this side we said this is ay vector. No, you can shift that vector and we can say this side over here is ay vector. You can shift it, right? And you can actually apply the triangular laws, right, to resolve. If you want, now you can apply triangular laws to get the answer. Abhijay, that is actually right, Abhijay, you got the right one. Okay, so similarly, ay vector that you have over here, right, you can shift that also, right? So you can shift the x vector also. So if this is actually your ay vector, means a vector, in this case we said that's no, because these two sides are equal, we can say this is ax vector. Clear? We can just shift the vectors because these two sides are equal and they are also, which means they have magnitude the same and they are giving the same direction. Alright, Radhima, I hope that is clear. Okay, now let's take the unit vectors in these two cases. Right, Abhijay seems to have given the answer in this case. Right, so we have two vectors, one ax and that ax vector over here. Okay, so we're going to resolve this. We're going to write it. Ridhima, okay, thank you, Ridhima, for that. And let's say we are going to write this in terms of unit vectors. The simplest way you can understand a unit vector is, what we are going to do, we have ax vector over here. We are going to chop it into unit vectors. Let's say this is unit vector, means its magnitude, unit vector magnitude is 1. Okay, so we are going to take unit vectors. Let's say this is, okay, and each unit vector value is I cap. To give the unit vector, we say this is equal to I cap. Okay, so ax vector over here, we can say in terms of unit vector if you're writing, right, then we can write that as what is the magnitude of this value over here? That will be given by ax, okay, into I cap. That will be your unit vector. We have done unit vectors before, but the simplest way you can take is with an example. I will tell you once again. In this case, let's say this magnitude is, if this is a vector, okay, or ax vector, and let's say its magnitude is 4. Okay, let's say it has a magnitude of 4. So what we can say, okay, 4 into it has some direction component. What we are going to say, we are going to take unit vectors, okay, that goes in this direction only, and we are going to take, so this was 4, its magnitude was 4, right? So instead of that one long ax vector, we are going to use unit vectors, like, 4 unit vectors. And we are going to say this ax is nothing but, okay, 4 times, right? That 4 times is what just gives you the length or the magnitude of this ax vector, right? Okay, and we are going to say 4 times ax, because it just gives you that length ax, right, into this unit vector. We will give it a name as I cap because it's in the x direction, right, into I cap. This is simple addition, right? Instead of saying I plus I plus I plus I, we're going to say ax into I. Why ax? Because that's the length. So a unit vector, using a unit vector, what we can do? You can give its direction, because unit vector will always have the direction. See, look at the unit vector. The unit vector, whatever was the direction of the ax vector, the unit vector was also in the same direction. So you have unit vector into the scalar quantity. Okay, that's why we want unit vectors. Why? Because now there I have a vector which has a magnitude 1 and I got a scalar quantity. Now it's easy for me to calculate. Right? So here I can write this ax as the magnitude into the unit vector that we have taken over here. Right? Similarly, ay also, instead of keeping this vector, we can write it in terms of unit vectors. Okay? So here we are going to say that the magnitude, this side, the magnitude is ay into what is this made of? Unit vector j cap. Okay. Now, from here, if you actually want to find what is the resultant vector over here, okay, that you can actually give it as ax. Okay, first we saw it was ax vector plus ay vector, right, according to parallelogram law of addition. Now ax vector is what? This we have replaced with the unit vector, right? That is ax into I vector plus ay into, that is the scalar component, into j vector. Okay, now this gives you your resultant, but this time we have just used unit vectors. Unit vectors has the same direction as your original vector, but it just has a magnitude of 1, and with that we also get the scalar quantity. Now it becomes easier for calculation. So if you guys have any doubt, once again just ask me the doubts in the chat box. Alright. Okay. Now this equation that we have over here, this gives you the rectangular components of this vector A. Okay. Now if we say this A vector makes an angle theta with this x-axis over here, right? This is our x and y axis, right? Okay. Now from here we can say that if you want, okay, A vector, right? From here we can say if, okay, from here we can say if A vector is making an angle theta with the x-axis over here, okay, very simply we can say, I'm just going to, from here we can say this ax, what is the value of this ax over here? If you want the value of ax, now what we can do is we can move this aj that we have over here, right? Okay, let that even stay here, but ax, if you want, you can just say we want this component over here. We want this component over here. What we see is a triangle, right? Meaning you can actually shift the vector that you have over here, ay vector, you can actually shift it. This is also ay into j cap. Now if you want the magnitude ax over here, right? Now you have a triangle. You can make use of trigonometry. You want this angle over here. How would you get ax? Which angle would you use in this case? We want ay, we want this ax over here, right? So we have a component over here. We are just trying to find the magnitude. Okay. So here you have a triangle over here. This is ax, right? Then if you want ax, how would you get it? Ridhima, in this case we want that is all right, but here we want, you can use sine, but would you get ax this side over here? We want to find the value of this side. But very good point, Ridhima. We are going to make use of trig and we would be using sine. But for this side over here, what we need is, let's do both. Let's do both sine theta as well as let's do both cos theta. Rishabh is also saying sine. Okay. Let's do both sine and cos. Okay. Now we have a triangle over here, right? What will be sine? What will be sine? Sine is given by sine trigonometric function, sine is given by your perpendicular by, that is right, Abhishek, sine is given by, Ritima, that is correct, perpendicular by base. What is your perpendicular here? AY, right? By perpendicular by hypotenuse, H, right? Sine is given by perpendicular by hypotenuse, that is sine is given by this angle by this, okay? So that means that is actually AY by A, right? From here we get the component AY, that is this side, the magnitude is nothing but A into sine theta, okay? And Abhishek, you gave the right answer for cos theta over here, okay? When you're taking cos, you will get, cos is actually given by, Abhishek, you got the right answer for both sine theta and cos theta, that is you got the both AY and AX correctly, that is right. Here cos theta, if you take, cos theta is actually given by, is basically given by what? It is given by this base by hypotenuse, okay? Base over here is AX by hypotenuse is A, the magnitude value, okay? From here you can say AX is nothing but A cos theta. Alright, now if you want to find, we have a triangle over here, right? If you actually want to find what is A and theta value, okay? Reverse, if you want to find what is A and theta value, what can we do? Right, I'll quickly do this. We said this is AX, this is AY, right? And the resultant is actually A, right? We are going to do the reverse right now. What we are going to do is, we resolve this component, we resolve this A vector into AX and AY, right? If I want the value of A as well as this angle theta, right? How would I get it? What method can I use to get the answer? So here I can make use of, see, if it's in a triangle, right? It is basically like a right angle triangle. I can make use of Pythagoras theorem. I can say my hypotenuse square Yatharth, I'm not very good. I'm not a native Hindi speaker, so my Hindi is very rustic. I'm not very good at it. I'm not able to completely understand what you're trying to tell me. Alright, I'm really sorry about that. And here the resultant, if you take, this is a right angle triangle. So this is A square, okay, is equal to what? It will be this hypotenuse square. Oh, that is great, Yatharth. So this A over here, right? Hypotenuse square is equal to, in this case, it will be my base plus perpendicular, right? That will be the value. Now let's substitute. We had got, right now we have resolved this A vector into AX and AY. Now we are trying to find the magnitude. We have resolved it. Now finally we have to get a value for it, right? We have to find the magnitude as well as the direction of this A vector, right? So let's find the magnitude. So magnitude in this case, we saw that AX is what? AX is A cos theta, right? AX vector, we can say this is A cos theta the whole square. Similarly, AY vector is what? In this case, it is A sin theta. A sin theta the whole square, okay? So from here you can take, this is nothing but, okay, A square cos square theta plus A square sin square theta, right? So here, let's start with this point, right? We started with this point, that is taking AX square plus AY square, right? What is cos square theta? Ritima, the answer is correct. Cos square theta plus sin square theta, the value is 1, okay? So if you see, your let me write it again over here. AX square plus AY square is equal to, in this case you will get sin square theta plus cos square theta is 1, so you get A square, okay? So from here this a is nothing but root of ax square plus ay square. So any place you have the component of two vectors, then you can use this formula to find what will be the resultant vector. Okay, this is how you find the magnitude of a vector over here. We just did the reverse calculation. Because we were doing resolution of a vector, right? Initially what we did, we know a vector, we found how to find these two vectors. If you want to find what is the, because you're splitting this vector, right? If you want to find what is ax vector or aj vector, you can use this formula. So whenever you're saying what is the x component or the horizontal component, you use cos theta. Okay. Tuang, hi, hello, I hope I'm pronouncing your name right. And if you want to find the vertical component, then you use ay is equal to, you can with unit vector also. Unit vector in this case what we have done, Ridhima, yes you can, but with unit vector means unit vector has the magnitude 1 and it's just telling you which direction it is going. Okay, it just makes calculation easier. Okay, so here whenever in a question, if they have given this result, if they have given a particular vector and they are asking you to find its components, then there are only two components. One is your horizontal component and a vertical component. To find the horizontal component, you use this formula. The horizontal component will be a cos theta, right? A into cos theta will give you that horizontal component. The magnitude of this value with cos theta will give you the horizontal component. And if you want the vertical component, what will you do? Whatever this a is into sin theta will give you the vertical component. We did the reverse of it. Okay. Now what we did the reverse of it. If we add these two values, we are getting the magnitude of this a vectors. In case in a question, if they have given the horizontal and the vertical component, and if they are asking you to find the resultant, then this is the formula. You square the horizontal and the vertical component and you take the square root of it. That will give you the resultant. Okay. Now, how would you find the direction? Now, whenever we take a direction, what we do is, with respect to this horizontal component, how many degrees should I move above to get the direction of this component? So, let's say from this horizontal component, 10 degrees if you move, and in that direction is the resultant one. Okay. That's how we find it when you're finding a resultant of a vector. So over here, if you want to find theta, if you want to find the value of, if you want to find the direction of a vector, okay, we're going to find how to find the theta value. Alright. So that you can actually do. In this case, what do we have? Ax in this side when you're talking about, this is basically ax cos theta, right? This is ay sin theta. Now, if you want this theta component over here, okay, the resultant is actually made up of these two vectors. Adding these two vectors will give you this vector going in the reverse, okay. Then what can we say over here? What are the effect of these two values should be my a. So, from here we can say, if you take sin theta by cos theta, if you divide these two vectors, okay, sin by cos is basically giving you tan, right? That will be what? In this case you will get sin theta is what? In this case you will get ax by ay. That is what, that's all you're doing. All you're doing is you're dividing these two values. Okay. This ax is nothing but this ax value. Let me just substitute. This ax is nothing but a cos theta. Ay value is nothing but a sin theta. Okay. What we are going to do is, we are going to divide ay by ax. That will give us a sin theta by a cos theta. Right? Sin theta and cos theta, actually a and a cancels. And sin by cos is nothing but tan theta. Right? Now, from here, if you take theta, that will be tan inverse of ay by ax. Okay? So, in any question, if they had given you this being the direction of your, let's say this particular direction is given. Let's say velocity in the east, in the due east is given. Okay. And they've also said another velocity is towards north. And they are asking you to find what is the, what will be the resultant. Okay. Then find the theta value. And from this initial value, you can actually say what is the theta value over here. Let's say theta is around 45 degrees. Okay. This being east. 45 degrees from east, right? Okay, this being your east direction, and if they are saying the final vector is 45 direction, let's say this is north, right? Then this will be south, and this is actually east. This resultant west, right? The resultant in this case, rather than 40, let's say this vector is given, velocity is some velocity, it's actually given. And if the resultant is given by this side, means let's say this is 45 degrees, means the resultant velocity is actually going in the northeast direction. Okay, so using this theta equation over here, we can actually find which direction the resultant A vector is. Okay, so very simple. Given these two resolution, if they have given the horizontal component and the vertical component in the question, and they are asking you to find what is the actual vector, use this formula over here, and for direction, use this formula over here. So once again, what will be the example? Okay, because we are coming towards the end of the class. What is an example of resolution of a vector? Walking is actually an example of resolution of a vector. Okay, so whenever you're walking, when you're walking, basically the ground feels slightly the ground actually, it will feel like it's slightly slanted. Okay, whatever the force this ground is exerting on you, the ground, whatever force is exerting on you, you actually exert an equal force on the ground. Okay, so that particular force, right, that is given by the ground reaction force, right? This is the force that is acting on the ground. Okay, and when you're walking, this particular force, the ground is acting on you is in a slightly it is slowly sort of slanted. Okay, so this resultant can be resolved into two components. One is in this horizontal component, that will give you your r cos theta, and vertical component which will give you your r sin theta. Okay, and again more about these courses, more about the applications of vector. Tomorrow, same timing, we will be doing it in the Unacademy platform. That will not be like the question, like the theory session, like the one we did now. That session will be completely just applications of vector. We will also solve some numericals based on just real life examples. Okay, so that's the focus of the class, and that class is again tomorrow at 7:45. The link for the class is in the description box below. You can just go to class 11 and you can go to applications of vector part 3 and you can register over there, and we can continue more about this in tomorrow's class as well. Now, before I end the class, few announcements. We have a limited period offer for ICSE and ISC learners. Okay, and in case if you're interested in taking a subscription plan, do take them between 5th to 8th June, because very soon the price will also hike. Okay, so between 5th to 8th June, whatever subscription you're taking, in case if you're taking a 1-year subscription, you will get 1 more month subscription free, absolutely free, and also you get a creative corner of 3 months. Creative corners will actually have some type of courses which are not actually the traditional, not like a physics, chemistry, math or biology. It can be like Vedic math or chess. Okay, you can check out what are the creative corners courses that are there. Okay, that gives you a free, so you're getting that particular course for 3 months free. If in case you're taking for 1.5 years, 2 years two more months subscription is actually free for plus classes, and as well as you get a 3 months creative corners. If you're taking 2 years course, then you get 3 months of plus subscription with 6 months of creative corners extension. All right, now this is for both, not only for ISC learners, for ICSE learners also this is applicable, right? And to get this, avail this offer, you can actually use my code MTIS10. So on top of whatever limited period offer we have between 5th to 8th, if you're using my code, you will get a 10% off. All right. Now, if you have any questions, you can ask me in the chat box regarding the classes or anything you have, right, regarding whatever we have learned till now. Any questions you have, you can ask me in the chat box right now. Shritima, thank you so much, Shritima. All right. And for the upcoming plus classes, right, we have a plus batch Brahmastra starting for class 11. Now, this course starts on July 6th. The focus of this course is going to be your midterm syllabus coverage. Okay, this course is going to be in English, and whenever you're taking a plus subscription with Unacademy, you're getting 4 subjects, that is physics, chemistry, maths and biology. So physics we meet every 5:15 to 6:15 between every Tuesday, Thursday and Saturday, and the course duration is going to be 1 hour. So physics I'll be taking, math Rahul sir will take, Manisha ma'am will take chemistry, and biology Lakshay sir will take. Now, in case you're a class 11, if you're in class 11 and you're planning to take a subscription, you guys are in a complete advantage. If you take a class 11 subscription for about a year, like you're getting a class 12 subscription absolutely free. So you're paying for 1 year, but you're getting the courses for 2 years. Okay. Now, whenever you're taking a plus subscription, since you're getting 4 classes, in a month, there will be minimum of at least 10 classes for each subject. So in a month, you're getting at least 40 core classes, 40 hours in total for all 4 subjects. Alright. Now, similar to these class 12, class 11, we also have an upcoming class 12 course, which is actually an Achiever course. This is an ongoing course. Abhijay, thank you so much. And in case of your whenever you're taking this Achiever course, right, we started this course a bit early because it's for class 12. We wanted you to have more revision going forward in the year. Okay. So again, for physics, we meet every Monday, Wednesday, Friday between 5:15 to 6:15 p.m. But Achiever's course, or let it be your class 11 Brahmastra course, the focus is going to be your midterm syllabus coverage. We'll be covering your first 5 chapters. Okay. And again, to get whatever plans that are available, like for example the limited period offer, and also to get a 10% off, you can use my code MTIS10. Okay. Now with that note, we are coming towards the end of the class. So I want you guys to do something, because last month we have covered unit 1, right? So what I want you to do is, you can check out my community link. The link is in the description box. There will be many MCQ type questions. You can go attempt to score pool questions. The question will basically be from your unit 1 only. Okay. And check whether you can answer them, and if you can't, just there will be upcoming numerical classes for class 11 on the Unacademy platform, right? And you can register for those as well, in case if you're not able to answer them. And the unit 1, again, few classes, because we have done that in the previous class. Unit 1 again will be covered in the Unacademy platform in forms of numericals. We'll mainly only concentrate on numericals, but you can still come to the class, and if you have any doubts, you can ask me as well. Okay. And Bucks Bounty, in case in any of the videos, if you're seeing any inappropriate content, and if you're reporting the same, you can claim a prize. With this, we are coming towards the end of the class. Like the class and share it among your friends if you like the class. Subscribe to the channel, so whenever there is an upcoming classes, not just with me, other educators as well, you would be notified, and click on the bell icon to get notification as well. Alright. Thank you guys. It was really nice. It was a really great session to have an interactive session, right? And thank you, Ridhima, and thank you, Abhijay, and I'll see you guys in the next class. Take care. Bye.